Let us consider a DC motor. The armature of the DC motor, say, has a radius of r meters. It is rotating at a speed of n revolutions per minute about the point O. Now, a current carrying conductor placed on the surface of the armature will experience a force. Let the force be in this direction. Then we can write the torque T is equals to force multiplied by the radial distance about which the force is acting. Now, if I just see the work done in one revolution, this will be equals to force multiplied by the distance moved. Now the conductor is experiencing a force of F, and the distance moved by the armature, which has a radius of R, okay, will be 2 pi R. So we can write this as 2 pi multiplied by F multiplied by R. So this comes to be 2 pi multiplied by the torque. Now the work done per minute will be equals to work done for one revolution multiplied by the speed n rpm, revolutions per minute. The same work done, if you calculate in 1 second, this will be equals to 2 pi T n upon 60. So the work done will be, that is, when the armature is rotating, the work done is nothing but the mechanical power developed. Therefore, we have the mechanical power developed which is equals to EB multiplied by IA. Okay, this is equals to 2 pi T n upon 60. In this expression, EB, it is called as a back EMF. It is called so because the induced EMF in the conductors as the armature rotates in the magnetic field produced by the poles opposes the supply voltage what is given to the armature of the motor. Since it is opposing the supply voltage, we call this induced EMF as back EMF, and it is represented by letter EB. Now this back EMF is also an induced EMF. Therefore, I can write the expression for the back EMF as phi Zn upon 60 into P over A multiplied by IA. This is equals to 2 pi T n upon 60. So if I write an expression for the torque, by simplifying this, I will be getting an expression phi Z upon 60 P by A IA and then 1 by 2 pi. This is the expression for the torque. I can simplify this 1 upon 2 pi 60 and I can write this as 0.159, okay, and I can further simplify this expression. But if you look at this expression, for a given DC motor, If the flux is constant, the other terms being the physical parameters, that is the number of poles, number of conductors, A, which depends on the type of winding, only variable is Ia. Therefore, we can write that the armature torque developed T will be proportional to the armature current provided the flux remains constant. If the flux is also variable, then I can write that T will be proportional to the product of phi Ia. T is equals to 0.159 phi Z P upon A Ia.